Yo, what's going on? Hey, Master Coach Guyett here with Battle Ropes Education. Yo, check it out, Kettlebell Kings. You're gonna see a lot more of that coming soon. So, hey, real quick, so I'm gonna kind of talk through Battle Ropes just a little bit, but then I'm also going to, in that conversation, talk about metabolic pathways. And I'm just gonna kind of brush over it. If you wanna learn a lot more about it, check out my continuing education. It's going to be found on Living.Fit. Right now, you can go to battleropes.org and check it out. And then, of course, there's a plethora of exercises and information on my Instagram at BattleRopeExercises. So, first things first, we got research done on the rope. The ropes are being manufactured right now, and then they will be shipped, and then we will make them available to all of you who want the very best ropes. These are braided, they're not twisted, so you don't have to worry about that untwisting issue. It can handle any direction, any rotation, anything like that. They're a bit on the heavier side, which actually is a good thing for progressive overload. You can get 1.5", 2", and 3". So check it out. And then for the outside ropes, we have this canvas covered rope, which is a triple strand twist, but it's underneath a canvas. So we've got all the angles covered, whether you're training outside for yourself, or you're training inside for yourself, or you're at a gym, or boot camp, or what have you, right? So check it out. Gravity ground, kettlebell, barbell, stacked weight, right? Again, amplification of gravity. These are not necessarily amplifications of gravity, but gravity still plays a role. Transfer of force production, and power output is found in the resistance here. How far you pull it, how hard you pull it. On this rower, I don't know if you could tell that that's a rower. Airdyne, right? Same thing. It's on the sprocket and then the flywheel here. And then the skier, same thing, right? And then the wave, a little bit different, but very more similar to these tools than these tools. So why am I even talking about that? So the battle rope, if you can harness the variables and understand them, quantify them, then you can program for them. In the same way that we program workouts, right? We utilize power output, we utilize force production, and then we do it in a certain way to hit certain muscle groups or certain movement patterns to get those stronger, whether it's nervously connecting and firing more muscle fibers, or building bigger muscle fibers, or improving the biochemical interchange and the metabolic pathway for that biochemical interchange. There's a ton of stuff that goes on there, but we all, in all walks of life, in order to program, we use power output. So force times distance over time is going to be the equation that I use. There's other equations that are the same thing, but just different, like force times velocity or something like that. But I'm just going to use these for this sake. Mass times acceleration equals our force, so that force up there. So if I can increase force, I will increase power output. If I can increase distance, I can increase power output, all other things remaining the same, right? If I decrease time, meaning I go faster, then I can increase power output. So this works for the kettlebell, right? But this is in the field, in the vector of gravity, right? So we have to position our bodies in certain ways in order to work certain kinetic chains or muscles for this amplified gravity tool. Same thing with a barbell, same thing with the stacked weight. The stacked weight, however, redistributes the weight one for one with the one pulley, right? So you're lifting the same weight, generally speaking. If you use multiple pulleys, then it kind of changes the mechanical advantage, and we won't even go into that, right? But I can redirect it so I can kind of pull it at a different vector, or pull it straight down, even though the weight is going up, if that makes sense, right? So if I can move more weight, right, then I can increase my mass, which will increase my force. Boom. But over here, it's a little bit different. So the force, right, the mass, yeah, it's our mass, but it's more about the resistance going on there to create a mass-like effect. And then so acceleration, distance, and time is more of the variables that we're going to change, because the resistance stays the same until you pull maybe more times, then that flywheel will get going and momentum will then be on your side. I just got a message from Marcus Martinez, Kettlebell Exercises on Instagram. Sorry about that, guys. And then the airdyne, same thing, right? So it's the resistance on that flywheel that creates. But the cool part is power output, right, is measured in amps. So measured in watts. It's measured in watts, wattages. So you can actually see the watts that you're producing per pull, right? See the watts that you're producing, see the watts that you're producing. So something that we don't think about, power output is per iteration. So one rep creates one amount of power output. If I do 2 reps, it doesn't all of a sudden multiply or add power output and I generate more power output. It just adds volume. So because of that, right, I will increase the weight and so I'll do more reps if the weight is lighter to get a training effect or an adaptation. Or I'll make it heavier to get a training effect or an adaptation. So making it heavier and lifting it faster and more distance is going to increase the power output. So maybe I'm trying to do a 1 rep max. So it's the max force, the max weight that I can bear and press through that particular range of motion. Whereas maybe if I'm training barbell or let's say kettlebell, right, aerobically, I'm going to reduce the weight and I'm going to do a lot more reps continuously with a lot less rest or no rest for a long period of time, right? And whether I cover great distances or not, and that's going to reduce my power output but allow me to do it for longer, thus helping create adaptations in my aerobic capacity or work capacity, right? And we can do the same thing here. We just don't pull as hard because, right, if you've ever done a 1-minute sprint where you go as hard as you can, like you're about to die. That's the glycolytic capacity, lactic capacity, and you feel like you're going to vomit and you can't move your legs. And yeah, everybody's been there. If you haven't been there, do a 1-minute sprint on the rower or on the airdyne or on the ski erg and you will feel what I'm talking about. This is where the rope comes in. So if I can glean out the force, the distance, and the time in a wave and quantify that, now I can actually train with a rope. And so that's exactly what I talk about in my 4-day, 4-day, that's a lot of days, 4-hour certification. I go even more in depth and give you very practical advice, pragmatic advice to programming in the 2-day, and then in my continuing education as well. I dive deep into how that works, what are the physics involved in a wave, how from those physics can we pull the variables that we use for these tools and these tools so that I can actually program. And if we can program, now we have a tool that if you use waves is concentric only, which is great for in-season athletes. You can move it in any direction. It's fluid as long as it's relative to that anchor, or you can take it off the anchor and move it in even more fashion, right? And you can program it for as long as you have a big enough rope, a thick enough rope, and a long enough rope. You can program it for max power output and create adaptations in your phosphagen energy system, as well as your just max output force, whether it's force production or max power output. We can adjust and create strength gains or lactic gains or glycolytic gains, which will also create fiber gains. And so if you're trying to get bigger, we can do that as well. And then from the aerobic side, obviously most people know that this tool can be used for that. But it's incredible because we can have kind of running 2.0 where we're moving in all sorts of different directions, have high variability of movement, as well as high work capacity. So hope you enjoyed that. Make your next one your best one. I will see you next time.